Hi everyone, we are from G2G Group. We'll explain about what is waste to chemical. What is waste to chemical? Waste to chemical defined as transforming a waste or residue or even a raw material into a usable chemicals, energy and also fuels. For example, transforming a waste to biofuels and renewable chemicals, which it aims to reduce the greenhouse gas emissions by more than 60% when compared with fossil fuel production and landfill operations. In the last decade, green chemistry has been attracting for a great interest in many contexts by designing chemicals, chemical innovation, and also commercial products with its aims to avoid toxics and reduce waste. Green chemistry can bring benefits towards human health, environmental, and also towards the economic development. Therefore, the implementation of circular economy is a fundamental step to create a better use of resources.
Next is the discussion on challenges in converting waste to chemicals. This is by treating waste and residue to produce energy, fuels, and other useful chemicals. To relate with Green Chemistry Principle 1, waste prevention, the early stage design system need to be considered. However, by treating the waste using life cycle assessment tools, proven that numerous materials give prevail over impacts. This is done by doing advances in valorization of renewable resources from the waste to the chemicals. The challenges can be observed from number 1, citrus production waste CPW, and number 2, production of green corrosion inhibitors GCI. The benefit and the ways to overcome the challenges for this production is number 1, for CPW, its wastewater characterization of citrus production has valuable compounds such as the fibers, the phenolic compounds, sugar, and organic acids, which is good for natural extraction. For its solid waste is an organic waste that is high fermentability due to high carbohydrate content that can accelerate degradation of waste. As for green corrosion inhibitors, for us to get economical saving sampling is that its organic molecules of natural product inhibitors from the fruits and the vegetables tends to absorb on metal surface. It is better to aim at corrosion inhibition effect at desirable area. This is by getting extracted molecules from the natural product with heteroatoms and unsaturated bonds. Theoretically before proceeding to industrial scale waste treatment. And it is also important to have specific and selected matrices and waste source from stating reasonable waste source to characterization of extract and identification of main compound for inhibition properties.
Commonly, food waste is the source of value-added chemicals and materials. A biorefinery perspective. The use of food waste is now further used for the feed purpose and is a part of the second generation biorefineries. Lactic acid is a part of the C3 group together with glycerol, malonic acid, and propionic acid. These components play a crucial role in building blocks from the biorefinery perspective. The high cost of pure carbon and nitrogen usually make use for the lactic acid production with LAB, lactobacillus, and lactococcus, and these studies have been improved by using food waste. This process is using the fermentation with LAB or decouple it with the previous hydrolysis. Waste cooking oil are essential sources of lipids. They undergo a chemical process to obtain the valuable chemicals in it. By definition, surfactants are acyclic substances that can reduce surface oil tension. They can be used as emulsifiers, dispersants, or forming agents.
Next, we have the principles of green chemistry that relates to the examples of waste-to-chemicals field. As we know, there are 12 principles of green chemistry. 6 of these principles, which are principles 1, 3, 4, 7, 9, and 10, relate to the examples given. The first principle is waste prevention. In our example of lactic acid production, waste is prevented by using food waste as feedstock. By using feedstock that is readily available and easy to biodegrade, waste that end up in landfills can be reduced. The next principle is designing less hazardous chemical synthesis. In lactic acid production, food waste is mixed with lactic acid bacteria to ferment. This process of producing lactic acid is safer than using pure carbon and nitrogen sources. Moving on to the next principle, which is designing safer chemicals. In lactic acid production, lactate esters can be obtained from lactic acid. Lactate esters are known as green solvent as they do not pose any threats to humans and the environment. In biosurfactant production, biosurfactant from biodiesel have chemical structures like rhamnolipids and sulforolipids that have low toxicity and are biodegradable. Principle 7 is using renewable resources or feedstock, which is applied in both examples of waste-to-chemicals field. For instance, in lactic acid production, cornstarch is used to feed the lactic acid fermentation, while in producing biosurfactant, waste cooking oil is used. Waste cooking oil is also used in growing housefly larvae. Trans-esterified chicken fat has also been known to be biolubricant feedstock. Another principle related to this field is using catalysts. Zinc oxide nanoparticles is known to be a good catalyst to obtain lactite, which is needed in polylactic production. The last principle is designed for degradation. For example, polylactic acid is biodegradable due to the presence of the activity of the terminal decomposers like microorganisms or fungi. Not only that, biolubricants are biodegradable as they have components that contribute to their biodegradability.
Now, what could be the benefits from this new innovation? Lactic acid, which is the product from this waste, has many benefits as it's used for flavoring agents and to produce polylactic acid, which is a biodegradable plastics. As we can see, polylactic acids, a polymer from lactic acid, bring a lot of advantages in the making of photoplastics, food packaging, clothes, baby diapers, and many other things, in which to make a better improvement toward our environment without impacting our food security. The benefits of this acid is it does not require costly sterilization, does not require addition of antibiotics, and use low-cost solid organic waste as a feedstock. Next, biolubricants. Biolubricants such as liquid lubricants based on plant oils or synthetic ester manufactured from the modified renewable oils, which is made from animals, minerals, and also vegetable oils. These type of lubricants can help in many equipments to do its job longer, more consistently, and more effectively. Biosurfactant also provide a good ability to reduce the surface tensions and can be used as emulsifiers, depressants, or even as a foaming agent. They also considered as important use in formulation of cosmetics, foods, and also in pharmaceuticals.
For our topic about waste to chemicals, to be concluded, all the transformation of any form waste of source to new formation of product such as chemicals, energy as fuels, and other materials has become the ways to solve as well as to reduce the pollution that transpire our environment. The transformation may involve any aspect in a ways to defy that scientists try to form a product. This is when the application of green chemistry applied. According to the principles of green chemistry, principle 1, 3, 4, 7, 9, and 10 was related to our topic, which we highlighted earlier in waste to chemicals field. As conclusion, the ways of following these principles are: first, to subset a life cycle assessment thinking; second, It's an innovative way to deal with chemicals. And the third, the last one, to set the goal on making the chemicals and the product with no harmful effect by design. Thank you for watching.